We're graphing rational functions, except this time we're working with linear function over linear function. And so if you look at our numerator here, which is 2x plus 5, set numerator to 0, which is 2x equals negative 5, or x equals negative 5 halves. So x equals negative 5 halves is going to be our x-intercept. Set denominator to 0, which is x plus 2. Denominator 0 will give you x equals negative 2. So we have to graph our vertical asymptote. And so here is our vertical asymptote at x equals negative 2. Again, to do long division to get our horizontal and oblique asymptotes. So pause the video here, do the long division so you can check your answer with me. So assuming you've come back from doing your long division, let's see if you got the same answer then. X plus 2 is our denominator, 2x plus 5 is our numerator, x times 2 is 2x, 2 times 2 is 4, and so we have 2x minus 2x is gone, 5 minus 4 is 1. So 2 is our quotient, which means it's a constant, which means we have horizontal asymptote. So we have y equals 2, which is our horizontal asymptote. So to graph it, take your horizontal asymptote tool and place the asymptote. If you're doing it paper pencil, you'd have to graph 2 points and then just connect them with a line and make a dotted line for asymptotes. That's how you plot asymptotes. Now for the points, 2 points to the left of negative 2, say negative 3, negative 4. 2 points to the right of negative 2, say negative 1, 0. Let's make our chart. And so you can verify that these are the coordinates when you plug in negative 4 and 4x into this rational function. We'll do the first one together. 2 times negative 4 is negative 8, plus 5 is 3. Negative 4 plus 2 is negative 2. Negative 3 over negative 2 is positive 3 halves. And then you can check that all of these are correct, and let's just enter them here. Negative 3 and 1. Negative 1 and 3. And 0 and 5 halves. Again, remember, when you plug in x equals 0, that gives you your y-intercept. So 0, 5 halves is our y-intercept. Remember, we also plotted our x-intercept. Do you remember what that was? That was negative 5 halves, and which means the y-coordinate would be? Good, 0. That's what it means to plot x-intercept. So there's our x-intercept. So you should always have x and y intercepts so you can see what's going on in the graph, and then use that tool to connect. And so there's your graph. Just like before, but it's a little bit shifted. Do you see why it's shifted? See if you can figure out why the graph from before is different than this one. And then also, what's the difference between constant over a polynomial, which is bigger degree, or same degree? Start making connections as to what happens to the asymptotes if the polynomials numerator denominator have same degrees, different degrees, and we will summarize it all together in just a little bit. All right, continue with your own examples then.